Hello, I'm David Schlack for electronicsvideoblog.com. Welcome to this introduction to computer-aided design. This is just an introduction. It is not meant to be a comprehensive guide to CAD. Things will be left unsaid that some might consider fundamental to the topic. As always, we invite your comments and suggestions about this presentation. Should you wish to spend more time on any given slide, simply pause the video until you are ready to continue. Wikipedia defines technical drawing as the academic discipline of creating standardized technical drawings by professionals of various vocations. It goes on to say that standards and conventions for various aspects of these technical drawings are used to create drawings that are ideally interpreted in only one way. In other words, give me a proper map of the object of your drawings, and I should be able to reproduce it. Types of technical drawings include architectural drawings, frequently called blueprints. These show the details of how buildings are constructed. Another type of technical drawings are structural drawings, which show the construction details of bridges, towers, buildings, and other objects. Mechanical technical drawings reveal the details of how machine parts are constructed. Exploded views, often called assembly drawings, show how various mechanical parts fit together to construct some piece of machinery. Cutaway technical drawings are those with a portion of the finished product removed or made semi-transparent so that some part of its interior detail can be observed. Electrical assembly drawings show how the components of an electrical system are wired together. Sometimes electrical assembly drawings are laid out in a way referred to as a highway diagram. Electrical technical drawings at the circuit level are called schematic diagrams. After schematic design is complete, circuits are typically soldered to printed circuit boards. Much thought needs to be given to component layout to design an efficient PCB. The drawing containing this design is called the PCB layout, PCB artwork, or simply PCB. Wikipedia further defines computer-aided manufacturing, or CAM, as the use of computer-based software tools to assist in the manufacturing process of a product. It also says that these CAM tools are made possible using computer-aided design, or CAD, software programs. Wikipedia defines CAD as the use of computer software programs to design objects either real or virtual. For the remainder of this presentation, we will be specifically interested in electronic circuit CAD. And, one more time, Wikipedia defines electronic design automation as that category of CAD tools that are specific to electronic circuit schematics and printed circuit boards. These are sometimes referred to as electronic computer-aided design tools, or ECAD. From this point on, we will use the terms CAD and ECAD interchangeably. CAD drawings come in two flavors. The first is the traditional, flat, two-dimensional drawing. The second is the more visually appealing, three-dimensional drawing. Now we will examine some necessary and fundamental CAD features, without which the CAD tool is greatly limited. The first must include the ability to graphically construct schematics of desired circuits. Another fundamental feature is the ability to import the schematic into a PCB design editor, in which the layout of the PCB can then be concluded. If the PCB design is to be produced in any quantity, or if it has particularly fine detail, it must be sent to a professional board house for manufacture. All board houses accept Gerber files, while they may not accept the native output files of a CAD program. Gerber files are the industry-accepted standard files for describing all elements of a PCB design. Other necessary CAD features start with relative ease of use. Design Rules Check and Electrical Rules Check are features that examine the schematic in PCB for industry standard or user-defined characteristics. These could be clearances, pad sizes, drill sizes, etc. And since new electrical devices are being introduced every day, no CAD software will have every existing component in its delivered database, so the ability to create custom components and use them in your work is essential. Additional features, which are not necessary in a CAD package, but which are certainly desirable, include the ability to simulate the electrical characteristics of the design circuit. If the simulation reveals a flaw, the design can be changed before an initial prototype is constructed. The ability to view a populated PCB three-dimensionally could aid in the design of stacked PCBs which must fit together. 3D views could also be an invaluable aid to a company's sales force. Other desirable features include the ability to export the design in a variety of graphical formats. It could be very useful to be able to generate PCB layout artwork as either a positive or as a negative vector graphic. Then there are the desirable features of being able to place components in a PCB design automatically, as well as to automatically route the board's traces. A note of caution on these last two desirable features. No software with these features will do as good a job as a practiced designer, and in the hands of a novice, these features could make an unacceptable finished product. This chart from Wikipedia compares some of the many CAD tools available to designers. These tools vary in price and function. We'll pause for a brief moment to give you an opportunity to view the various entries. Unless one is a professional circuit designing engineer, a free CAD tool should definitely be considered. Professional tools can cost well over $1,000. There is a wide range of features and capability among free tools. This chart, also from Wikipedia, compares some of the free tools currently available. We will now pause to give you a chance to examine this chart. Why should every electronics professional and hobbyist learn CAD? First of all, so that you can properly document your design. It is much easier to claim ownership of a properly documented design than of one that isn't. Then, when it is time to duplicate or modify your design, documentation makes the job easier and provides a record of the revision process. And, should you ever wish to automate board production, documentation will prove to be invaluable. An analogy might sum it up fairly well. Schematics are the recipes from which electronic circuits can be built, whereas populated PCBs are the finished cuisine made from those recipes. CAD makes the cooking experience more professional. Now is the time to choose your own CAD tool, from the many that are free or from those that are commercially available. Choose something that you are confident you will like. And I wish you happy CADing.